Welcome to BKW Physics. I'm Mr. McConley, and today we're going to do some demonstration, and we're going to use a parallel laser light source, and we're going to do some refractions. And we're going to start with a basic refraction in which I have this large refracting block of glass, and if I keep the glass so that the laser light is hitting it perpendicular, the laser light goes straight through. However, when I start to have the lasers, here we go, hit at angles, probably you can see it pretty well there. Now let me turn it this way. I'm trying to get you so you got a good view. Okay. I want you to look at the back side of this where the lasers are leaving the chunk of glass. And you'll notice two things. First of all, some of the light is leaving, and you can see on my hand, it's hitting my hand, so it's going right out the other side. But some of the light is bouncing back this way. And what we learned the other day is this is the concept of total internal reflection. And so I must be getting real close to the angle of total internal reflection, the critical angle we called it, because I'm getting some that's bouncing back in. Now if I go a little bit further here, I don't know if I'm going to be able to go far enough. I'll try it with a different chunk of glass in a moment. But in the meantime, let's look at some other things that you can refract light through. If I use this chunk of glass, which is thicker in the middle, thinner on the edges, it's better that way. You can see that what happens is the light is bent, refracted, varying amounts because of the thickness of the glass. So what ends up happening is that because each part of it's getting bent, varying amounts, the light all crisscrosses at one focal point right here. Okay? This is the way the lens in your eye works. This is the way your, if you have glasses or contacts, you are bending the light, refracting the light. Now a person that wore glasses that were thicker in the middle would be a person that was farsighted but couldn't see up close. And if you can't see up close, you would wear glasses that are thicker in the middle. The majority of people, though, your age that need glasses, need them for seeing far. And if you need glasses for seeing far, you are actually wearing a pair of glasses that is like this, where the glass is thicker on the edges and thinner in the middle. So what it actually does, if you can see what's happening here, it's taking the light and it's dispersing it or spreading it out. And so what happens is your eyeball, the lens in your eyeball, is this type of lens, which is actually called converging lens because it converges the light. And your glasses are a diverging lens. So the light gets diverged and then it gets reconverged with your eyeball, and it focuses on the correct spot on the back of your eye. So you can see we're refracting light with these, which is pretty darn cool. Let me try one more thing with this particular block here. The reason I use this block is because it has different angles. And if you follow different laser beams, you can see different things happening. For instance, this laser beam comes in, it bounces off the back, it gets refracted quite a bit, and it goes this way. This one, this way. But you'll also note that there is some of the laser that bounces straight off the surface, because remember, when you change materials, part of the wave is transmitted and part of the wave is not transmitted or reflected. So you're seeing both things in this situation. The last thing I want to do, if I just shut this down for a minute, is take a laser pointer, and I'm going to shine it through that big chunk of glass again. And I want to determine what the end value is of this chunk of glass. Okay? And the way we'll do that is like this. I'm first of all going to outline this chunk of glass so I don't wiggle it halfway through the demonstration and ruin everything. Okay? I'm also going to put a target mark here where I want the light to enter. If I could have an assistant come up and just hold this for me, it would make it a little bit easier. So my assistant's going to hold the chunk of glass, just basically keeping it on the outlined parameters there. And I'm going to shine the laser pointer into the glass. Try not to shine it in anybody's eyes. Okay? So, here we go. I'm going to shine it in at this angle. The laser is starting here. Oops. Get that right. It's entering the glass there, and it's exiting the glass here. And you can see, thank you very much, you can see if I connect these lines that the light was coming in at that angle, but since it's coming out over here, you can see that there was quite a bit of bending happening there. And that bending is the refraction. Here's your theta 1. Here is your theta 2. This is your N1, and this is your N2. I want to know what's my N2. So all I got to do is measure the other angles. So real quickly, if we were to take a protractor out here and measure these angles, this is going to be a little off because obviously, it's a little rough. I'm kind of doing some of this freehand, but we're going to measure this angle as being a 23-degree angle. We're going to measure this one as being a 36-degree angle. We know that we started in air, so the n value is 1. So, can you use Snell's law to figure out N2? Try it out. For today, physics.